There we go. Good morning. Thank you for coming to the Argo Workflows and Events community meeting on the 17th of March, 2021. I'm just going to give you a quick overview of what we're going to do today. We've got two presentations today. The first one is from Eduardo Blancas, and it's going to be on streamlined machine learning using Argo with Argo Workflows with Ploomber. Is it Ploomber? Correct me if I'm wrong. And then we've got a second presentation from Rush.
That's right.
That's right. Is it great? And then we've got a second presentation from Rush Tehrani at Onepanel. He's going to show you a demonstration of using Argo with Onepanel, which is an open source piece of software to do computer vision automation, which I think is going to be really interesting. And then finally, I'm going to share out some of the survey results from the Argo Workflows survey that we've had earlier on this year and tell you what we think about that, and hopefully be interesting to get people's commentary on that as well. If you haven't already, please do add yourself to the attendees list here. I know that there's more attendees than people listed here, so it's always great to find out who's coming along to these meetings and what you're interested in. For those of you who don't know, Argo Workflows and Events, they are basically a small ecosystem of cloud native, highly scalable workflow automation tools. Argo Events is used for triggering workflows typically, or other actions on Kubernetes, and Workflows is typically used for large workflows on Kubernetes. Myself, I'm the principal engineer on Argo Workflows and Argo Events, and we have a couple of other Argo core engineers here as well. If you want to ask questions, this is a great opportunity to pick the brains of people who work on this every day. If you do want to ask questions, I mean, you can typically ask straightforwardly just by unmuting and asking yourselves, or you can come and ask on the Zoom chat and somebody will ask your question out if your microphone's not ready. And you can also ask further questions by coming on to Slack, our Slack channel afterwards. We do record these meetings, and then we typically share the recordings out on YouTube, uploaded to YouTube to share out to other people. If you've got some colleagues who you think might be interested, I do try and make sure that all the timestamps are in those videos, so you can just fast forward to the particular piece of interest to you as well. Okay, so that's all the preamble done with, all the introduction done with. Eduardo, are you ready?
I am, yes.
Okay, I'll hand over control to you now.
Okay, thanks. Gonna share my screen. Okay. Is everyone able to see my screen? All right. So thanks everyone for joining today, and thanks Alex for inviting me to present my project. So as Alex mentioned, I am going to be speaking about Ploomber, which is a project that I've been working on for a little bit over a year. And specifically how Ploomber integrates with Argo for lean machine learning workflows. Just some background about me. I've been doing data science and machine learning for the last 6 years in projects spanning working with government, some academic research, and more recently in industry. In the last few years, I've been focusing on the deployment of machine learning in business critical settings in the financial industry. So really the motivation to start this project was my daily job, because I just wanted something that gave me some assurance that the way my model works in development, it would work in production, and to automate all this process of taking my notebooks and my scripts and my functions in a way that we could make predictions and use the model. So let's start speaking about machine learning deployment and training. It's complicated to get models into production for many reasons. And one of those reasons is the difference between the tools that we use in development versus the ones that we use in production, in deployment. Data scientists, we usually use a combination of Jupyter notebooks, scripts, functions, and frameworks like PyTorch or scikit-learn. And when we want to take our models to production, we use a production-ready system like Argo Workflows in this case. And one of the problems is that the difference in these tools force us to change our code if we want to run it in a production environment. So we may want to take our notebooks and scripts, and if we want to make predictions using Argo workflows, we may have to change the code, right? For example, if we have a notebook, we may have to convert it into a script and maybe expose a command line interface so we can code it as a step in an Argo workflow. And this is a really risky process because the moment we start moving different pieces to our pipeline, the pipeline that we were developing locally or in a single server, we may break things. And it usually happens that when we start moving a lot of things, we are not able to reproduce our results. Maybe we had a certain quality metrics about our model, and now we compute them and they are no longer true. Because we move a lot of things, we don't know exactly at which point we broke the model. And even before we make a deployment, we may want to use a system like Argo workflows for training. If we want to train different models, especially because machine learning is really experimental, so we don't know exactly which model is going to work. We may be training a neural network, a random forest, or support vector machine. We don't know which one is going to work best. And if we have access to a Kubernetes cluster, it's a good idea to try and leverage these compute resources and use our development pipeline to train hundreds of models at the same time. So it's a combination of these two ideas, deployment, but also using these for training models on a larger scale. And as I mentioned, these things, when we start modifying our code, we may break our model. And on top of this is not something that we only have to do once, right? Every time we change our model, every time we find something that we can improve, or maybe we found an error in our pre-processing steps, we have to modify the pipeline and we have to deploy again. So this is something that has to happen very often. And the easier for us to streamline this process, the more robust our machine learning pipeline is going to be, because the moment we find an issue, we are going to be able to fix it and automate the deployment process. Now, that's the motivation behind Ploomber. The idea is to provide a simple API and a good development environment so that we can use whatever tool we like. If we like Python scripts, if we like Jupyter notebooks, if we are doing deep learning with PyTorch or classical machine learning with scikit-learn, whatever tools we like and make us the most productive, we should use those. And then do not force us to make a lot of changes in order to run this in production. That's the main motivation for Ploomber. And one of the main features of Ploomber is to offer a really simple API. The reason is that when we are doing machine learning, we don't know what's going to work. So we are experimenting a lot of things. We try different models. We may try different pre-processing steps. So there should be an easy way for us to modify our pipeline and see if we are making progress. It's like a really experimental kind of projects in machine learning. So this is the API. It's actually really simple, similar to Argo workflows. We just have a YAML file. And the only two things that we have to specify is where's our source code. So in this case, we have a task, which is a function in a module called tasks and a function called get. And it saves an output here. And we just repeat the same logic for every task in our pipeline. We generate some features, we join all the features, and we finally use a script to train a model. And then we generate an evaluation report and the model that we may want to use in production. So now, just to make things more clear, I am going to show a demo, and you can take a look at the code here if you want. Okay, so, first, there's a repo with all the examples, and actually you don't have to install anything. So I'm showing the repo with examples. You can click here or here, and this is going to open a Jupyter lab environment, and you can just try the examples here. Or if you want to run locally, you can use these commands. Okay, so now I am going to run one of the examples. First, I'm going to show how the training pipeline looks like. Using a plot, and I'm using Ploomber to generate this chart. So let's open this. This project has a training pipeline and a serving pipeline, so I'm going to generate both so we can see the differences. Serve PNG. Okay. So as you can see, the top one is the training pipeline. They look really similar, and they should be. When we are training a model, we get historical data, we generate some features, the three tasks here in the middle, and then we train a model. when we want to make predictions, we get new data, maybe data that was generated in the previous month or week or even one day. So we get new data, we run the same pre-processing steps in the middle, and then we load a previously trained model and make predictions. And this is also one of the most common problems when deploying machine learning pipelines, that we have to make sure that all the pre-processing steps that we make to everything that we do to the data in training happens in the exact same way in production. This is a problem called training serving skew. And this happens when the pre-processing steps don't match. And Ploomber offers a way to compose pipelines so you can make sure that this is happening. Okay, so I'll just keep one of these here, and I'm going to show how this looks like in code. So you can see on the left side that I have the declaration of the pipeline. And all I'm saying is I am gonna get some data using a function. Here, I'm going to show the code in a little bit. So we are going to get the data, we are gonna save it here, and then we are going to import our feature generation pipeline. This is optional. And the reason why I'm importing tasks from a different file is because I want to use this for training and serving, but you could just have everything here. And then finally, I am going to train a model using this script, right? And this generates this pipeline. Now, if we take a look at the serving pipeline, we're going to see it's really similar, right? This is a training pipeline, this is a serving pipeline. We are also importing the features, so these 3 tasks. Instead, we are getting some new data, let's say data from the last month, and then we are using a previously trained model to make a prediction. So we are saying use this model and save the predictions here. Now let's take a look at the actual code. This is just the declaration of the pipeline. I'm going to open the task that gets some data. It's really simple. All you have to do is to declare this as a function, and you can use whatever framework you want inside the function. The only requirement is to follow this convention. You should have a product argument, and you should use this value to save your output. So just getting some sample data and using this product argument to save my output. So this is the get task, doesn't have any dependencies. Now let's take a look at some of the tasks that have dependencies. Okay, here. A really similar thing, just one new thing, that we have an upstream argument. Now I am saying that the sepal area task, the one here, has to use get, the output of get as input. So all I have to do is say upstream get, and Ploomber is going to use these references to build the pipeline. So you don't have to explicitly state dependencies. You only have to make references to other tasks. And then when you run this function, this value is going to be the output of this task. And that's it. That's all we have to do. We repeat the same process for different functions, and it's the same logic. So I'm going to run this locally. This is one of the important features to run these pipelines locally. Sometimes before we run these in Argo workflows, we may want to make sure that the pipeline actually runs. We may be adding some features or adding some pre-processing steps. So if we run this pipeline with a sample, let's say 1% of the data, it's going to run really fast, and it's going to make sure that it runs. Very often it has happened to me that I have a pipeline that I just modify a really tiny thing, and I think it's just going to work. And then I send that to a cluster, and then I wait for 2 hours, and then it breaks. So this is just a nice sanity check. So I run the training pipeline. This is just with a simple command how you run it. And I'm going to show the output. This is also a nice feature that Ploomber has. So I'm going to show the output of the training step. So let's go back to the pipeline declaration. So I'm saying I'm going to use this script and then generate the model and an HTML report. So if you are running this in Argo workflows, and this works the same locally and in Argo workflows. So if you're running this in Argo, I'm going to show an example of running in Argo after this. You want to train a model, but you also want to know if the model is good, right? So this is how it works. Every time you use a script, that's the difference between using a function and a script. If you use a script, Ploomber is going to convert this to a notebook first, and then it's going to execute it. So you have your fit script here on the left side, and here you have the output version. You can hide the code if you want. But this is really, really handy. You can just train your model and then get this nice report back and take a look at the numbers and the metrics. And you don't have to save any other files, any extra files. You can have a single standalone HTML report. So this has been really convenient for me when I train multiple models and I want to find which is the best one. So that's just how it works locally. Now, I'm going to play a video that shows how to it runs in Argo just to make things smoother. This is the same example that I've been showing, same code. So the first thing I do is I run this supervisor export code. This is another package that we are developing, and this takes care of exporting to Argo. So you can see I just ran this command in the project folder, and then it generates the YAML spec to run to use in Argo workflow. So you can see on the left side that I got the YAML spec, and then I'm going to run this this pipeline. This is the training pipeline. So I submit it, and now I have the training pipeline. So I'm gonna fast forward this. So you can see it's running the first task that gets the data. It's gonna install the dependencies. Then it should run the task somewhere here, runs the task. And then it's gonna start running the upcoming task, which are the two that generate the features here. And it's really simple. So you only have to export, run this export command, and it generates that, the YAML spec for you. Another thing that I forgot to mention that it's also really useful when you are working locally is the interactive console. So if you do Ploomber interact, you get an interactive command interface, and you can get your pipeline, tag variable. So you can ask which are the tasks in this pipeline. You can get the specific task, let's say, and this is really convenient to debug pipelines. Once they start growing and you have dozens of tasks, this is really convenient. You can ask for the source code, the upstream dependencies, and even start a debugging session here and just run things. That's a high-level summary of the different features. So if I'm looking for early adopters and contributors. So if you are interested in being part of this project, please reach out to me. You can pip install Ploomber. The code is on GitHub. And as I mentioned before, there's a repo with some examples. You can run this in the command line. You can also use Binder, which is going to set up a Jupyter Lab environment for you. And you can try that with no setup. You don't have to install anything. So that's it. I think we have a few minutes for questions.
I think Dan's saying great presentation. So Eduardo, it doesn't sound like we have too many questions. So thank you very much for coming and doing that presentation for us today. I really enjoyed it. I'd like to hear about the different use cases, particularly in machine learning. So that's great. Thank you very much. Okay, so up next we have Rush. Oh, did we have a question? Maybe I'm hearing things. So next up we have Rush from Onepanel. He's going to be talking about computer vision. Rush, are you ready to start?
I am. Let me share my screen.
Right.
And we'll go from there. Go. Are you able to see my screen now? Perfect. Hey everyone, I'm Rush Tehrani, and thank you for having me and the Onepanel team, and thanks to Alex for inviting us to have this presentation. Today I'll be talking about automating computer vision workflows with Onepanel and Argo. So, and just so you know who I am, I'm actually one of the founders and the creators of Onepanel, one of the developers, and we have other developers, core team members on this call as well. So just to know to give you an idea of what Onepanel is, we call Onepanel, it's an open and extensible IDE for computer vision. And the way it works is we provide built-in tools for the entire ML lifecycle specifically for computer vision. And then one thing we do on top of that is not only you have these built-in tools, we allow you to bring in your own tools and models in this whole process. And the way we do that is we make sure that we're following open standards, and our open standards are very much Kubernetes native YAML and Docker images. And that's kind of where Argo comes into play in this whole picture as well.
Hey, Rush, I'm sorry to interrupt, but you seem to be sharing your presenter view as opposed to the other view, in case you wanted to correct that.
Yes, thank you. Thanks for letting me
know.
All right, let me Google. There it is. I think this is the right one, hopefully.
Yes, looks much better.
All right, thank you. So to give you an idea of what kind of this end-to-end workflow looks like and the ML lifecycle for computer vision, we have, Onepanel kind of covers a big subset of it. And you have the data preparation, you have the prepare kind of stage of the whole lifecycle where you use computer vision annotation tools or annotation tools. You do automatic annotation in this phase, and then you also do data augmentation pre-processing. For the build, and then the next step is actually building your models. And in that case, you are using Jupyter Lab and VS Code workspaces. And you could use our built-in algorithms or bring in your own, as always, and you can also bring in your own tools as well into this whole pipeline. Again, I'll show this in the demo. And then finally, one of the other steps is training and tuning your models. So we have the training pipelines and the hyperparameter tuning pipelines, which allows you to use different hyperparameters for your models as you're training them. And then you can, again, run these on multiple GPUs in parallel as you like. And then finally, you can actually do visualization of how your model is being trained as training and how it's being tuned as well. And then finally, you want to deploy the model, which you can do. And also what you also want to do is you want to kind of orchestrate this entire workflow and automate it. So for example, you want to come back and have your annotators kind of do the annotation, use the model that's been trained for pre-annotation and so on. So you can actually automate this entire workflow that we have in place as well. And just so you know, this whole process is very continuous and iterative. So automating it, it's going to make it a lot quicker. So instead of taking days or weeks, you are getting you're going through this process a lot quicker. You're doing it in hours. So to give you an idea of what we use, we basically bring some best-in-class open source technologies and basically integrate them together into this one unified interface. So here's a list of the technologies and I kind of go through what they're used for each. So we use Argo for deploying Kubernetes resources like Istio, stateful sets, and so on. We also use it for data pipelines and training pipelines. And then we also use Argo for orchestrating that end-to-end workflow I just mentioned earlier. We also have TensorFlow and PyTorch, which are the deep learning frameworks. And again, you can bring in your own tools and your own frameworks in here as well. It's just, again, YAML and Docker images. And then we have CVAT for image and video annotation. And we use NNI for hyperparameter tuning. And soon enough, we'll have NNI for neural architecture search, which allows you to kind of come up with your own model architectures on the fly and even compare multiple model architectures for your particular data. Jupyter and VS Code are workspaces. And again, as data scientists use those for coding and just notebooks and building their models and building their data augmentation, coding their data augmentation pipelines. And then you can finally deploy that into in a workflow right from the Jupyter notebook, and I'll show that in the demo. And last but not least, we have cooler integration for, so you're able to actually declare these workflows in Python as opposed to YAML, and again, run these workflows directly from Jupyter Lab as you're testing and coding. So just a quick overview of why we picked Argo versus some other options. Really, our requirements were it should be Kubernetes native. That was a hard requirement because it goes with our goals. Proven scalability, organizations actually using the product at scale. Active community and speed of bug fixes and new features, which we can see by looking at GitHub. And Argo checked all those requirements. Airflow was a no-go for us because it's not Kubernetes native. You can run it in Kubernetes as an operator, I believe, but you can't declare your workflows as YAML, Kubernetes native YAML. And Tekton looked great overall, but it's very much specifically designed for CI/CD. Even if you go talk to the developers, that's what they say. And Argo is a more general purpose. It's a more general purpose workflow engine. So I'm going to jump into the demo now and talk about that. So as I mentioned earlier, there's data preparation. There's the entire life cycle that's in Onepanel, and where it usually starts is with annotation. And just to give you an idea, basically what you do with annotation is you're trying to come up, basically annotate and label issues in let's say, for object detection or semantic segmentation. In this case, we're trying to identify potholes. This is an actual real use case. And we are annotating that in CVAT to make that happen. Some of the other use cases for Onepanel, just out of the community, are defects detection in manufacturing, object detection for robotic arms, and tree damage detection is another one where insect damage detection in trees caused by rhino beetle is another one. So a lot of it is all about object detection and semantic segmentation. This is a semantic segmentation example. If you look at this one, this other task here, we're trying to identify guardrail damage. So this one is not damaged, but there's other ones that are here that are damaged. This one's obviously damaged. And what's great about this whole environment is that once you do your annotation, you can actually easily train it from right in your CVAT environment. This is enabled by a Python SDK. So you can see the training workflows and pipelines that are available in the system. So this one is, again, Argo workflow based. And I'll show you what this looks like. You can actually define these in Onepanel, and it will show up in any kind of environment you bring in via our Python SDK. And so this is kind of what this workflow looks like. It has a processing piece. It has the hyperparameter preprocessing, which is preprocessing your data, has a hyperparameter tuning, which again, I'll show you in more detail on what that looks like. And then finally is the metrics writer, which writes the metrics. And you can even add something to send notifications in Slack when a training is complete. And one feature that we have that's kind of nice is you can actually define these parameters with different types. So Argo has the parameters, but we also add these different types. So you can have a YAML type where you can define your pre-processing parameters. In this case, you can define how your hyperparameter tuning is done, like the search space and all the information in regards to the hyperparameter tuning, you can put it in as YAML. And we also have this node pool, node selector module where you can add as many of these as you like and have each task in your pipeline be kind of run on different machines. For example, pre-processing, you don't want to necessarily run it on CPUs, but training, you definitely want to run on a GPU or a TPU machine. So if you execute this workflow, it's going to take a little bit. So I've actually pre-launched one for you so we can take a look at it together. And so as I mentioned earlier, you have the pre-processing and hyperparameter tuning. What's really interesting about this hyperparameter tuning, or this particular task, is obviously you have the logs as you would get those with Argo, but there's this concept of what we call interactive sidecars, which allows you to bring in different visualization tools. So for example, this is the hyperparameter tuning visualization. You can kind of see how it's training and what kind of results you're getting based on the different hyperparameters you're trying. You have the tensor board, which is kind of showing your metrics as things are training, and then you can also bring in what we call glances, which is already integrated, and this actually allows you to see like how your resource usage for that particular task as it's training. Another interesting thing is we do have another sidecar here, which is a file server sidecar, and this is actually showing what's happening in the mounted volumes in this task. So you can actually see your model being generated live here, and it's essentially exposing your volumes from that particular task's pod or container. And so this is kind of like basically how the training works. And then what we do here is I'll show you how this all works. In the end, when this is finally trains, it creates a model, like the best model out of this it's possible models that you can depending on different parameters, it creates the best model for you. And you can actually take that model and bring it back into the annotation tool I just showed earlier. And what's great about our platform is you can essentially grab stuff from object storage and push them into any of these workspaces. So I want to push this into the models. And then I can just sync it to the workspace, and the data for my models are now going to be synced in this workspace. And then I can find it here. And then basically what you'll do is you essentially once you bring in that model, you can come back to the task here and do automatic annotation and select that model for automatic annotation. In this case, it's a mask RCNN object detector. Now, instead of your people going in and doing this manually every time, you can use the same model that you're training for object detection or semantic segmentation to also pre-annotate your data. So that cuts a lot of that manual processes down, and that again cuts down the whole end-to-end process that we have here. So what I showed you was what we have built in. We also have this concept of workspaces, which you saw the annotation tool in here. And with workspaces, you can actually bring in your different tools. And again, these are actually built in the back end. We use Argo workflow to actually deploy these and pause these and resume these. And you can actually switch these between CPUs and GPUs. Which is, again, if you're like, let's say using Jupyter Lab to do you're building your code in Jupyter Lab, you can switch to a GPU machine and do your test there. Another thing that's interesting here is I mentioned Cooler, and we are using Cooler here to define our pipeline in Python. So what you can do is you can go through this whole process and actually do your data augmentation in a Jupyter Lab notebook, and you can see the results, and you can kind of see the results here as I've augmented the data. And then the next step in the pipeline is the actual training on that data. And I can again train in Jupyter Lab notebook and kind of test my model out. And then once I'm ready, I can actually define those as a DAG via our Cooler integration, and then submit them to the platform. I think I didn't run, okay, so I didn't run this TensorFlow source. Now I'll do that again, and I should be able to submit. There you go. And we just created a workflow template in Onepanel. It's a Python defined workflow template. So it just got created by that cooler example I just showed earlier. And now it's also running the workflow as well. And then last but not least, we can actually, like I said, automate the entire workflow. And this is like a quick example of that. This is a pre-annotation workflow. So what it does is it just launches a workspace, which I showed it, the annotation workspace that I showed earlier. And you can create a CVAT, create the tasks and set the data for the task, and then use the model that you just trained to pre-annotate the data. So when your annotators show up the next day, everything's ready to go. They can just make adjustments and then do the whole training process again automatically. So that's pretty much as far as the demo is concerned. I kind of want to talk about some of the challenges we ran into while we were building this. So one of the main challenges is running this on multiple platforms. You have to deal with different ways to handle auto scaling. EKS has its own ways of doing it. GKE and AKS are a little bit easier to deal with. You have to have different GPU daemon sets depending on the provider. They have their own different daemon sets, and also storage classes and so on. So EKS was a little bit harder than the rest of them. Another interesting challenge for us was those interactive sidecars I showed earlier. How do you do those, and how do you make sure that they're garbage collected at the end? So we use Istio, and basically we had to make sure, and then we create Kubernetes resources deployments and services and virtual services to make those happen. So you have to make sure that those are cleaned up when the workflow is done. And then we also needed to support Azure Blob Storage and GCS across the board, not just in Argo, but across the board. So what we did there is we actually used the Minio gateway in between our S3 APIs, and then just to use the Minio gateway. So we are using S3 across the board, but then Minio gateway in between makes it possible to go to Azure Blob Storage and GCS at the same time. And last but not least, RBAC and network policy for namespace isolation. That's a big deal. These namespaces need to be separate because it could be different teams working in on different projects, and one team necessarily shouldn't have access to the other pieces, or annotators shouldn't have access to some certain types of data. So you want to make sure that separation exists. So thanks for listening. We have our GitHub repository listed over here, and our documentation is at docs.onepanel.ai. And if you like what we're doing and you find it useful, give us a star. We're always looking for contributors. And if you have any features you want to have us develop for you that we will find useful for the entire community, let us know. If you need have any questions or need help, join our Slack or ping me. I'm in Argo Slack too. You can feel free to DM me there as well.
Thanks, Rush. I see there's a question in the chat from Johan about, you mentioned that NNI is used to build the hyperparameter tuning functionality. Is there a particular reason for that choice, and have you looked into any of the Kubernetes native solutions such as Kubeflow, KATIB?
Yeah, that's a very good question. We did look at KATIB. NNI has a big community around it. So we decided to go with that, but KATIB is always an option. And I know it's definitely more Kubernetes native. We could potentially bring KATIB in as well. We do want to have multiple tools. So I think that's something we'll probably look at later. But we did look at it and just picked NNI because it also has, I think it's neural architecture search, and hyperparameter tuning was a little more mature than KATIB at this point.
Great, thanks.
Rush,
Awesome.
Thank you very much for that. That's a great presentation, really interesting. I really, you know this already, but I was really interested in your kind of sidecar model. This kind of, you've got an interactive sidecar, and I wondered if anybody else had been using something like this with with their workflows. 'Cause I would definitely be interested in typically any kind of workflow. I kind of want to get that feedback fast, especially if that workflow takes a while to execute. And that workflow itself can often tell me better than the infrastructure what it's doing, you know, where it's progressing, if it's having issues, if tests are failing. You know, I want to know if those tests are failing as soon as they fail, not, you know, wait the entire suite has ended. And I wonder if anybody else had similar use cases where an interactive sidecar would be useful to them. That sounds like a no. So it's just me in that case. Fine. Okay, let's moving on. So the last topic for today, let me see if I can find the right window here, is the Argo Workflows survey. So about a month and a half ago, we sent out 4 separate surveys, I believe. One about Argo workflows, one about Argo events, one about Argo CD, and one about Argo rollouts, which Henrik was involved in the last 2 of those. Now, this is obviously not the best forum to share out the Argo CD results, but it is a good forum to talk about Argo workflows and Argo events. I'm not going to talk about Argo events today, and the reason I'm not going to talk about them is because I have not really collated the results yet. And the reason I've not collated the results yet is because we didn't have quite so many respondents for that survey. I think we had less than 20 respondents, and I'm kind of cautious about making conclusions on those numbers. So today we're just going to focus on the Argo Workflow survey results. And I'm just really interested in getting people's thoughts on this as well. If anything jumps out to them as being interesting, and maybe I have a few questions for people who are listening today as well about this. So we did send out the survey. We got 60 responses, which is fantastic. And we computed an NPS score on that. That's Net Promoter Score. And that came out at 66, which is classified as, I think, exceptional. So we're very pleased to find out that people thought, you know, would be, you know, the average rating was exceptional. People were very pleased to recommend the product to us. When we looked at the kind of roles and use cases, it probably shouldn't surprise anybody. This was dominated by software engineers, 90% of it. We did wonder if we'd see more data scientists amongst this. And it kind of maybe hints to the fact that the people we got responding to the survey were maybe operators of Argo workflows rather than users of Argo workflows. But there's not very much we can do about that, I don't think. And the use cases were the same kind of 6 use cases that kind of dominated in 2020. So data processing use cases, machine learning, and an amount of CI/CD and infrastructure automation. One of the things we try and get feedback on a regular basis is about new features that we introduce. So we typically look to develop features that are popular and have clear use cases. And popular features are basically the ones that have got the most thumbs up in our issues list. So these are some of the features we developed over the last year. And you know, we weren't surprised to see things like workflow templates at the top of the list. And I was surprised to see how many users, half of all users use the API, and that kind of really validates that decision for us as well. But actually people aren't using memoization and semaphores and mutexes. So it's kind of harder to develop those features out, you know, if they're not so popular. So it's good, you know, it's good to kind of always feedback on features you're using on that. And you may have noticed that memoization, I think, appeared in roughly August. We haven't really kind of progressed that feature as a great deal, and I think this kind of reflects that. We were quite interested at people running at scale. So into it, we're probably getting on for 350 installations, 350 clusters, where we install Argo workflows for a variety of different use cases. And we've seen a lot more people using workflows at very large scale. You know, workflows with 10,000, 20,000, and 30,000 pods in them. Simon, I think you saw a larger one recently.
Yeah, we had a user notify us that gRPC doesn't even handle. So gRPC can't even handle a message size required to transmit his workflow that contains over 135,000 individual nodes in a single workflow.
So that may be the largest I've seen, I think.
Mm-hmm.
Let me know if you've got a bigger one. I think I've got a gallery of the biggest workflows I'm going to put together at some point. Okay, so this may be a bit of an area of interest too. So we looked and asked people what the biggest challenges that they had. And so my question here is that it came down to kind of one main thing, which was YAML. People found that a lot of users were unfamiliar with YAML and would prefer Python. But we know that we have a couple of ways to author workflows in Python. There is specifically the most popular way of doing that is using the Cooler DSL. And I wondered if people were aware of that, or they felt if their users were aware of that or not. No questions on that? Okay. What we're trying to understand at the moment is how much more we need to invest in a Python DSL. There is a ticket in the GitHub, and if you're interested in that, you can subscribe to that. People also thought about a couple of other areas, so improved UI, and so Argo Workflows 3.0, we're kind of ahead of the curve there on that with the new user interface in Argo Workflows 3.0, and improved areas of documentation. People were not clear about any areas of specific improvement. So we've created a ticket for people to highlight areas in documentation where they want specific improvements. One question was, well, why did people choose Argo Workflows? I have anonymized this section. I removed the products that people talked about this. No, sorry, not the users, but the products that people compared to. But the biggest factor was the fact it was cloud native. So there are other workflow managers out there, but they're not cloud native. And so Argo Workflows dominates as the best one that was there to do. And people also found it was really easy to use. So that was another key point. And the final thing is that people like to interop with other tools inside the Argo ecosystem, particularly using Argo CD. And we do that ourselves. We use Argo CD to install and manage Argo workflows and Argo workflow templates, and core components are managed using Argo CD as the installation. Just a little bit of next steps. I think I've mentioned this previously in this discussion. We need to figure out what we're going to do about like Python support. Do we need to promote this solution more, or do we need to provide more first-class support for Python in the software? And what areas of documentation specifically are you improving? How do we know what those are, and who can help us with that? Okay, that's the summary of this. Does anybody have any questions they would like to ask about the survey? Okay, a bit of silence there. Okay, well, that was the last topic for today in the community meeting. Thank you all for coming along today. If you do want to ask more questions or follow up, come and hunt us down on Slack to ask those questions, and we'll get back to this. And hopefully I'll have the recording available to share probably about this time tomorrow, certainly by the end of the week. If you're interested in presenting or coming along, we're really keen to have people come along and talk about the stuff that they've been doing and about Argo workflows and interesting use cases they've been doing. If you want to present, just look us up on Slack. We're also looking for people to come along and write guest blog posts. So if you want to talk a bit about Argo workflows or Argo events or Argo CD or Argo rollouts, we're really keen for people to come along and join and become a new guest post on our website. Okay.
Just a quick shout out before you close, Alex. So the call for papers for KubeCon North America is also open. So it would be really good to see some more Argo sessions there. And we'd be happy to help facilitate if you want. If you don't really know what you want to present on, if you're looking for someone to present with, we're happy to facilitate and help that as well. Generally, if you have more than 1% on a session, you increase your chances of getting accepted. So we're happy to help where we can there as well and work together to come up with some good sessions.
Okay, thank you very much and have a wonderful day. Bye-bye.